In this lesson we're going to look at the wave function questions in the Unit 3 Specimen 1 Higher Nab. First question, express 4 sin x plus 3 cos x in the form k sin x plus alpha, where k is bigger than 0 and a is between 0 and 360. So the first thing to do is write it out like this, so equating the two equations, and then expand this using the addition formula. Now that will be in the formula sheet, but sin, when you're expanding a bracket like this, goes to sin cos cos sin. So sin cos cos sin, the sin stays the same with the k in the front. Now what you want to do is you want to take your k and your cos a and write it in front of sin x like that. And you want to multiply through with the other side, so k times sin a and then the cos a at the back. Basically take the sin a and put it at the front and the k. This is where you equate the coefficients. So that bit is the bit in front of the sin. So we can say that bit's equal to 4. And this bit here is the bit in front of the cos. That's that bit there. So we can say that that's equal to 3. So if you rearrange that just to get cos alpha, then it's 4 divided by k. And sin alpha is equal to 3 divided by k. So this first bit we're going to try and work out k using a wee right angle triangle in Pythagoras. So draw a wee triangle out, put your alpha in, and we have to label the sides here with information. So basically we should know that cos is adjacent divided by hypotenuse. And we should also know that that's the adjacent, that's the hypotenuse, and that's the opposite side on the triangle. Hypotenuse you find opposite right angle, opposite the angle, and adjacent's the other one, underneath the angle. So because we know cos is adjacent over hypotenuse, we can put the 4 in as the adjacent side and k as the hypotenuse. The same with sin. Sin is equal to opposite over hypotenuse, so this is really O over h. Now the opposite side's here, so that's 3, and again the hypotenuse is k. So a bit of Pythagoras, k squared is equal to 3 squared plus 4 squared, so k is equal to the square root of that, which is just 5. Now to work out the angle here, you do a bit of right angle trigonometry. So tan is equal to opposite over adjacent, so it's 3 over 4. Get your acute angle first, so inverse tan 3 over 4 to give you 36.9. And then we have to work out what quadrant alpha is in. Now the way to do that is to look at your cos and your sin. Now in this instance cos is positive, so you tick the places on your cast diagram, your row sin tan cos diagram, where cos is positive, that's there and there. And sin is also positive here, there's a plus 3 over k. So sin's positive here and here. So we're really looking for first quadrant angle. So first quadrant angle would be just 0 plus 36.9, so it's just 36.9. So we've got the two main bits of information, k is 5 and alpha is 36.9. You just have to fill that into this here. And that'll get you all your marks at that point. Now, question 13. It says, given that 3 sin x plus 7 cos x is equal to this, we have to solve that equal to 2.8. So we're basically going to replace this here with that to make it easier to solve. So do that first. Now this is a trig equation that we have to undo in the correct order. The first process is to divide by root 58 and then work out what our acute angle is. We basically want to inverse cos 2.8 over root 58, and that comes out to be 68.4. The thing that people miss here is when you inverse cos, there's two solutions, and people just inverse cos and give the answer as 68.4, and then they add on the 23.2. If you work out your acute angle, you then have to go back and say, well, is cos positive or negative here? Well, cos is positive, and that happens in the first quadrant and also the fourth quadrant. So what you're doing here, you basically have to say, well, this equals this answer in the first quadrant, or 360 take away that, which gives you 291.6. Then to finish it off, add on your 23 to both answers.